all the best other speakers. And as I've said, ours is a supporting community. While Copilot helps us out with being an assistant and all the fancy things that Karan has just mentioned, our next speaker, Magesh, comes from Chennai. He's very heavy into the Ruby community, running the Ruby community in Chennai, as well as a mentor and a coach. With over a decade of experience, he's been coding in Ruby for the better part of 8+ years. And he is here to talk about a lot of Ruby, especially making it concurrent. Magesh, over to you.
All right. Hello. Am I audible? Good. Awesome. Before I start, I think we'll take a quick poll. How many of you have done concurrent programming? Like writing actual concurrent code? Okay, yeah, I can see a lot of people. Good. Okay. Yeah, sure, but I need. All right, cool. Let's get started. So today I'm going to be talking about threads, fibers, and Ractors, just to demystify for people who have not, read about it or probably seen or tried it, right? So my name is Magesh, and like you said, I am a dev coach at Railsfactory with like 13+ years of experience in this field. I'm pretty, active in the open source community in our Chennai. And you can follow me at iMagesh on all the social media. Cool. So this is my team. We went to watch the recent Rajinikanth movie. So I just want to show off a little bit. Sorry, Rajinikanth? No, let's edit it. All right, cool. So what is concurrency and parallelism? Right? So to start off with, I wanted to start off with a cute picture, so I got this. So this is concurrency, right? So concurrency is where we perform like multiple tasks in overlapping time periods, but they are not actually happening at the same time, not running simultaneously. But in parallelism, you run tasks, simultaneously. That's the difference. So if that doesn't explain, this should explain to you, right? Concurrency is about dealing with a lot of things at once, right? Dealing with, not doing, okay? And then this is parallelism, doing a lot of things at once. Okay, I have an even better picture. So talking about Rajinikanth, that is parallelism, okay? So now, does Ruby support concurrency and parallelism? Yeah, they do now. With Ruby 3.0, we have support for concurrency and parallelism. That's what we're going to talk about, right? So for concurrency, we have these three things, right? You might have seen threads a lot, but we'll actually go through that as well. And we'll look at what fiber is and Ractor also. 20 minutes is very less though, but let me see. So in computer, everything is a process, right? Anything that is running is going to be a process. Your browser is going to run a process, right? So if you want to run multiple things, you could create a process, but then creating process is very expensive, right? So the next thing that comes to our mind is, okay, from a process, can I create multiple threads, right? Because creating threads is better than creating processes. So that's the reason why we start playing around with threads. Okay? So in using threads in Ruby, can we achieve concurrency or parallelism? Concurrency, yes, but parallelism is not possible. Why? Because of the global interpreter lock, right? So we have this lock at the center, so it doesn't matter even if you write a program which has like multiple threads, you might be imagining that all these threads are going to run and do things faster, but the global interpreter lock is going to come and say, hey, stop there, I cannot let more than one thread pass me through, right? So that is a problem with interpreter lock, okay? So even if you write code that is multiple threaded, but it's not going to execute simultaneously. Right? So let's look at a thread program. I have to run through quickly, okay? So imagine, we have a simple example here, which is something that I'm using to scrape a set of URLs, okay? This could also be maybe calling a bunch of APIs to collect some data and do some processing on top of that, okay? So first thing is, we have like all the endpoints or the URLs that I wanted to scrape. And then next is, this is about the code where I actually do some little bit of processing, which is scraping some of the text from this thing. I'm using nokagri, if you see. Okay, and this is how you create threads, right? You do threads.new inside, and then you can iterate through all these APIs and then send a call. So for each endpoints, I can create separate threads so that, all the threads are going to run, concurrently and then do things faster. If I have to run this sequentially, it's going to take a lot of time. I have done this. I have benchmarked it, and I've seen that sequentially running takes a lot of time. But this one saves a lot of time for us, okay? So this is one way of doing this. Okay, so it works for simple use cases, yes, that is good. But imagine I have another code which is going to perform a bank transfer, right? Like from one account to another account. That is where, it gets complex, okay? So let's say there is 2 account, right? So I'm initializing it with some amount. It can be 1,000 or 100, whatever it might be, right? And then I'm going to mimic like creating multiple transactions, right? Transferring from one account to the other. So in this example, you see transfer method, which is going to transfer money from A to B. You can also imagine that there is a DB call involved, and it's going to actually debit from one account and credit to the other account, right? So when I do that, right, again, there is another loop. I'm creating more, transactions similar to that, but this time I'm doing it from B to A, okay? So now, do you think the thread program will work just fine? No, right? Because we have multiple threads here. So when transferring money, there can be a problem because sometimes there is a race condition that happens in thread. So because of that, the money, there will be some discrepancy in the data that you get, right? So to avoid that, what can we do? We have to do, probably, if you look into the function, I can probably use mutex, or I can use lock to actually lock before doing a withdrawal and then, transferring it to another account to make sure that this thing doesn't actually screw my code, right? And if I have to, then there is another problem that happens, that is deadlock, right? When one thread is waiting for another thread to release the lock and etc. So for avoiding that, I might have to probably sort the order in which I lock the thing. So that is, again, another thing that I have to do. And if you see, multiple locks involved, and then I withdraw, deposit, and then again unlock, right? It gets messy, right? So this is just a very simple example, but imagine if you're doing this for a production problem, right? You will be writing a lot of things. So using threads is not easy. You might have to think in a different way altogether to actually design the code in a specific manner to be able to actually make it work, right? It is messy actually and complex. So then, okay, let me switch back to the presentation. Then we have the next one, that is fiber. Right? So we saw thread, but the problem with thread is this, right? Every time when I'm making a transaction or something, you have to synchronize it, either using mutex or lock, you have to make sure that doesn't happen, right? Otherwise, you will end up with race conditions, and deadlock can also happen. And another problem is the data inconsistency. If you try multiple transactions like that, and you see there is a bunch of money missing in your account, right? So that is going to be a problem, okay? And in threads, context switching happens at the OS level, so that is also a little expensive. So next thing is, okay, let's look at other options. Fibers is one, okay? So this is probably the syntax that I can use. You can imagine fiber as something like thread, but it is controlled by me, the user, the developer, right? But in actual scene, the thread is actually managed by the OS. Right, so here I have the control as a developer to create something similar to threads, which is known as fiber, but I can have control about the context switching, right? So I can use fiber.new to create many fibers, and then I can use yield command to pause from within one fiber and to jump to another fiber for context switching, right? I can execute one task in one fiber and then jump to another fiber to actually call another one, and then again use the resume method to come back to the previous, and this is how I can shift context, right? I can do multiple stuff. Now, are fibers better than threads? Yes, creating 100 fibers is a lot faster than creating 100 threads, right? But there are caveats to fiber also, because it's manual management, right? You need to control the transfer, like from one place to another. If there are a bunch of fibers, you have to manage them efficiently. Like where do I pause? Where do I resume? All these things need to be done manually, right? And another issue is the starvation. That happens when one fiber is processing, but it forgets to yield, right? So then the control doesn't go to the next fiber at all. So one thing is executing and it stops. So that is another issue with fiber. Okay, to solve that problem, we have another gem, which is async. Okay, this actually takes a lot of the weight from you, so you don't have to do things manually. Instead, they give you a DSL or a syntax that you can use, which will be simple, and that will do things under the hood, managing these things using a scheduler, a fiber scheduler, which was released with Ruby 3. Okay, let's look at the fiber code again. Yeah, so this is a simple code, just for you to get the hang of it. Okay, so first we have a block where we create one fiber, and then, this is how you create a fiber, I told you, right? Fiber.new. And then here we have another block for creating another fiber, fiber2. Okay, and then when I run this, my call stack will start here, right? Because those things are just loaded into the memory, and here's where I call a function. So fiber1.resume is where I start, right? When I do that for the first time, it'll go here, and it'll initialize the fiber1, right? And it'll probably print the first statement inside it, and goes to the next line where I say fiber2.transfer, right? So it stops right there, and it jumps to the next fiber here. Okay, so it initializes fiber2, and then now it goes on executing that, right? So the putter statement gets printed, and then again I have fiber1.transfer, right? Again switching back to the previous. So what happens is when I switch back, it knows where it came from, so it can start, it can resume process from where it left, right? So it left at line number 5, and now it knows that next thing is line number 6, right? So there I have fiber yield, which is going to be a pause. So when I pause, I'm not transferring it to another fiber, I'm just taking a pause here. So what it does is it just comes out to the main program, right? So outside of both the fibers, and it does the next thing. So it resumes from where it started, right? So it puts the statement, and then it goes on to the next line, fiber1.resume, and it puts the final statement, and it's done with it, right? So here, what I can actually be doing is, in fiber1, I could actually trigger an API call, and while the API call is being fetched, I can actually pause and then switch to the next fiber, and then again I can do something else there, make a DB call or maybe do something like that, and again resume after the data has been retrieved, right? So these kind of things can be done concurrently with the help of fiber. Yeah. So this is the same example where what we are talking about, right? Scraping a website or using endpoints, whatever. Right? Same example, same code here, but here I'm using async gem to actually do the same thing. So if you notice, I'm not going to do that, yield, resume, start, and etc. Not here, right? So async gem does that for me if I just put the code within this async do block, right? So async do block, when I put it first, it creates a main task, and then if I keep using the block within it, it's going to create subtask. Right? And it manages it so well that it first waits for all the child tasks to be completed, and then it moves on to the parent task, right? So all these tasks are powered by fibers, and they are going to run concurrently, right? Which means you get the speed. Okay, same thing. So if you notice, there is another block here within, so that will become a subtask for me, right? So I'm going to create multiple subtasks. So all the subtasks get completed, and then the final block is going to return the data for me, okay? So this one works. So next is, let me go back. Okay, so in async gem, they have support for these multiple things. And this async gem was actually invited to be part of the Ruby core project, right? Mats himself invited the writer of this gem to be part of this, which means, they officially recognize this gem to be, working very well, right? So if you want to experiment fiber, you can start using async gem and do that, right? And Manu here is going to cover async gem later today, I think. So you should listen to his talk, right? So here I have async IO for doing any IO related stuff, and then HTTP for calling APIs, process for managing process, WebSockets, DNS, running RSpec, and so on, right? So the thing is, you need to have a library that is compatible with fiber if you want to do things, parallelly, right? Otherwise, you might be using a library that is going to be a blocking code, and you will be trying to write code to make it concurrent. That's not going to work, right? You need to have a non-blocking library to actually work with this, okay? Async gem actually does that. There is a feature with async gem where it actually allows you to use a blocking gem, but it will still try to run it in a non-blocking manner. Yeah. Cool. So then we have Ractors, right? So far we have seen threads, fiber. Now the last one is Ractor. With threads, the thing is, since the threads are managed by the OS or the runtime, it is usually expensive, right? Threads have shared memory, and because multiple threads are running and modifying the same state, there is a lot of chance of things going wrong, right? The same with fiber, but fiber has fiber gives the control to me as a developer, so I can choose to figure out how I write my code to avoid these race conditions and etc. Right? Fiber is very lightweight compared to a thread, but it does the same thing in a similar manner, right? With less amount of context switching, because context switching here happens from my side as a developer, but not from the OS level with fiber. So Ractor is again taking these things to the next level. So threads and fiber is going to help you run concurrent code, but Ractor here can actually help you write parallel code, right? Which means this is the code that you write is actually going to be running simultaneously, right? So that is the thing. Right? Let's say I have 4 CPU cores. I can create 4 different Ractors, and 4 Ractors can be running parallelly, processing similar tasks, right? So threads and fiber, they are good for mainly I/O related tasks. If I have to fetch a API or maybe make some DB queries or writing to a file, etc. Those things will be helpful if you do that. But they are not well intended for writing CPU intense tasks, right? So which is what Ractor solves. Ractor can be used to solve the CPU intense task, right? Ractor might not be able to help you with the I/O tasks, right? But it can help you with the CPU related task. So this is the syntax, how you get started. Same like fiber, I can create Ractor.new, okay? But when I create a new Ractor, it's almost like a process. A process does not share memory, right? So threads will share memory, but process does not share memory. So process will run in an isolated way. Same way, Ractor will also run in an isolated manner, which means the memory that it has is not shared with the other Ractors, right? So if you want to access something from the outside, within the Ractor, it's not going to be possible. That is tricky, right? So what I can do is, if I want to pass a data from the outside to the Ractor, a specific Ractor, I can use 2 different ways of communication. There is push and pull, okay? So first thing is Ractor.send, which is a push basically. So from one Ractor, from outside or from within a Ractor, I can use the send method to send a data. But again, sending this data is still limited because the data has to be immutable. You cannot send mutable data, and there is a restriction on certain objects that you can share within this, right? And then once you send the data, then I can use Ractor.receive to receive that data coming from that, right? Similar way, there is another way of commuting, right? There I'm sending data, here I can actually yield data, right? So when I'm executing something and I have something to print out, I can yield it, and then finally use the take method wherever I want to actually take it and show it to the user, right? Because when 2 Ractors are running, you have to, you cannot share things within, right? Which is why we are sending messages from one to the other to actually pass object here and there if you want to call that, right? True parallelism is possible with Ractor, right? Like we saw, it isn't working with threads, right? Because of the GAL. But with Ractor, you don't have the GAL issue. Although there is a Ractor level lock, but you actually escape the GIL, which means your Ruby code can run multiple times parallelly. So with this diagram, there are multiple Ractors running at the same time. I can send messages from one to the other, any direction, right? So that shouldn't be an issue. Okay, we already talked about it. So let's look at a Ractor example. Okay, let's say I have to, for this exercise, I thought I'll show something very simple, so it's easier. And maybe it's a CPU intense task that will work with Ractor. So I have a method that generates some dummy product, right? A JSON-based product that you can imagine. This might work in a real-life scenario also. Maybe you can imagine that this JSON data is being fetched from another API or something like that, okay? Or it's being streamed to you from a particular URL, okay? So then I want to transform the product from one format to another format for a different purpose, right? So we normally do these kind of formatting for data. So this function is intended to do that. Okay, so here I am planning to create a Ractor, right? So this function is going to create Ractors. So whenever I want to create Ractors, I'll call this. Within that, you see I'm using Ractor.receive and Ractor.yield. So Ractor.new is the syntax that I'm using, right? So here, what I'm going to do is, I'm going to create like 10,000 odd products, and then we are going to divide it into chunks of products, because I have, let's say, 4 core. I want to create 4 different Ractors to process simultaneously. So I have to divide that 10,000 product to 4 Ractors, right? So I'm going to divide that into small chunks, and we are going to be sending that from outside, not within here, right? So this Ractor function will be able to receive that from the outside and process it. After processing, it will be able to yield the result back out, right? So I can print it somewhere or store it somewhere using a DB call. Yeah, that is what I'm doing here. So here, I am creating the 10,000 mock data, and I'm also creating the chunk size, taking the total product, dividing it by a number of Ractors, and then calling the Ractor create function so that, it creates multiple Ractors. Okay, so from within here, what we do is we iterate through the Ractors. There are 4 Ractors, so I'll iterate through all the Ractors. We take one Ractor, and then we send a bunch of products to that using the Ractor.send, right? So there is a chunk size, which is managed by from and to, right? So 1 to 100, send 1 to 100 products to here, something like that, okay? So I can send it, which will go into the Ractor, but there is no other way I can, assign it to a variable or something and then call it that. It's not going to work because Ractors are running in isolated memory space, right? That is a problem, which is why we have to do this. We have to send the data there. Okay, I'm using send. And then at the end, when I want to print the data, I'm going to use concat, and I'm using Ractor.take, which is going to take the result from the yield that we called earlier, right? So yeah, so that's how this works. Yeah. Just wanted to show you the syntax so you get a feel of how these things work. Although the time is very less, I couldn't run it and show you, but yeah. So the problems with Ractor is the same. Since it's isolated memory, sharing data gets difficult. But if you look at threads, sharing data was the actual problem, because of that, there is chance of race condition and deadlock and etc. So to solve that, they have created something like this as a communication that can solve that problem, right? But it is still not very simple for you to write this code. You still have to think in a different way to be able to, send data. Like you have to freeze your existing objects and etc. and send it. So that needs you to, think in a different way, right? So limited shareable objects, that is one problem. You might get, if you try to run an experiment with this, you might run into a lot of errors initially because Ractor is still at experiment stage, right? And then gems are not compatible. I tried using some gems to see if I can show a good demo, but many of the gems are not compatible with Ractor at this point, right? I think the ecosystem will evolve to actually build more stuff. But right now, if you want to use Ractor within your code without actually introducing any third-party libraries, then it's a good thing, right? If you want to process something, then it's a good call, right? For the time being. But down the line, it might improve, okay? So yeah, so what to use? Threads, fibers, or Ractors? What do you guys think? It depends, right? So yeah, but what I liked was, I always looked at Node.js as an alternative to see, hey, Node.js has been doing async for a long time, using promise and all that. Why didn't Ruby, bring something like that? And now this is an answer for us. Fiber is a very good answer to Node.js from the Ruby community. So we can start using fibers to, do stuff in async manner, especially that async gem, right? Ractors, since it's experimental, it's not going to be possible for you to write a lot of code right now. Maybe once, slowly the community evolves, you can do more, right? But I would encourage you to try creating fibers, try using this async gem and experiment with that, yeah? Thank you so much for listening to me for the last 20 minutes.
Questions? We have one here.
Hey, yes.
How does it different, like passing a block around and calling yield on it?
I didn't get your question. Like passing your block, how?
Like you said, the Ractors, they are like
Ractors, fibers, both create
they would
blocks.
comprise the smallest unit of atomic work.
Correct.
Correct. And how does it different for if it is not, if I'm doing this, trying to achieve the same thing? I mean, what are the problems I would face if I'm trying to achieve the same thing?
With mutex.
By, if I'm passing a block around and calling it yield, and maybe I'm having a mutex around it, trying to achieve the same without
Right.
without using that library async.
Yes, yes, correct. With threads, it's still possible, right? Create thread, then you need to be aware of the design that is required for writing concurrent programs, right? How do you avoid deadlocks? You need to add locks, prioritize it, and etc. So not many people would be actually aware of this design that is required, right? And to avoid all your pitfalls that normally happens with the concurrent
So you
program.
are doing
With
the
threads.
heavy lifting here.
Sorry?
So your GM is doing the heavy lifting here, so not going into the
Correct,
unnecessary
correct. So I'm saying like
details.
with fiber, you can probably, like if you want to avoid that complexity, you could probably try async.
Okay, thank you.
Yes.
Yeah, hi, Magesh. So in the context of Ractor, you said that we should be using Ractor when we have a CPU-intensive
Correct.
process.
Correct.
Now, how much performance improvement do we get when we use Ractor? Like, if we are using directly Ruby via a single-thread model or something else, it's usually advisable that we should not use very CPU-intensive processes, like a video processing algorithm or some complex encryption algorithm. Now, in terms of using Ractor, how much performance improvement do we get? Like, it is,
Okay.
does it give any practical benefits in terms of
Yes, yes.
what we have already in the traditional Ruby?
Yes, yes, absolutely, actually. So if you look at the Ruby official doc, they have an example TAC program which is used for benchmarking these kind of parallel processing, right? So they use a recursive program which is going to take a lot of time, to run in the CPU. So when they benchmark with that, Mats was able to get a 3x performance, which is why they said 3 into 3, Ruby 3. So Ruby 3 promises 3x speed because one of the reasons was Ractor actually, because it has significant improvement in running things parallelly. Yeah, so if you try something, depending on the complexity of your logic, you would definitely get 3x, 4x of, outcome from that. I have tested, I have run some basic sample programs to, benchmark it, and I saw like significant improvement there. Yes.
Thank you.
Yes.
My question is around, as a community, Rails have been mostly using multi-threaded paradigm. Like we have Unicorn, we have
Correct,
Puma,
correct,
right?
correct.
So have you experimented or like have you gone through like how this is going to fit into Rails? So most of our applications, if you have seen many big applications, right, which is running on Nginx Puma, Unicorn Puma, right? Those sort of combination multi-threaded programs. Now,
Right.
what is the feature for the alternatives that you have proposed? How
Okay.
it's going to, because Rails is a big elephant,
Correct, correct.
right? It has a lot
Correct.
of dependencies. Unless and until these things come into Rails, this is gonna be, what is
True,
your view
true.
on how it's going to evolve into Rails as a package? Right? Thank you.
Doing things very well. It creates multiple processes, it can create multiple threads, and it's doing things very well, right? But you can use these things not within the Rails, not for serving your request directly, but for maybe background jobs, right? Let's say I'm processing like 1 million data, or even if I have like 10,000 plus data, I could still use these asynchronous features to process them in the background, not while serving the request to the user, right? Does that answer your question, or?
Yeah, maybe like Sidekick can be converted into fiber kind of things, what you're suggesting.
We can see more libraries like that in the future, which might use fiber, instead of threads to, accomplish the same thing. Yeah?
Yeah. So just to add on, it's actually one of the reasons why we organize RubyConf and not Railsconf. And I'll tell you why we do that too, is because when we are talking about Ruby, we want Ruby to be enhanced for concurrency and parallelism.
Correct.
Rails is a framework which is may choose or may not choose to utilize it or do it any different way.
Correct.
Sidekick, excellent gem. And Sidekick will use all the Ruby concurrency if you need it. So you can configure Sidekick for workers for any language per se, because it's getting a Redis pops up. So how it is translated into a framework would be different from the context of the language semantics itself.
Yeah.
Oops, I hogged the time. Hold on, let me get through the questions. One behind there, please.
Hi, Jay here.
Yes.
Can you tell us a little bit more about, underlying implementation of fiber and what is it, that making faster than threads?
Underlying issues with
Underlying
fiber, huh?
implementation of
Okay,
fiber.
Okay.
That's a whole talk in itself,
No, I mean,
Yes.
in brief.
Yes,
In
yes.
brief.
Okay,
I mean,
okay.
little bit if you can just more.
Okay, so the memory that thread uses is more than what a fiber uses, right? Fiber's memory is going to be lower, right? And then in threads, you have the context switching at an OS level or probably in the runtime level, which is going to, probably cause more problems than you controlling the context switching, right? So in fibers, we get to decide when to switch tasks and etc. But in that case, the OS or the runtime is going to use time slicing or something to pause at one time and do it. So when you have to context switch from one state to another, loading the state into the memory and then saving it somewhere, these things are expensive, right? So threads would be more expensive compared to fiber, right? I'm not saying you shouldn't use threads. You can use threads if you're very, very
Okay,
good
I
with
actually
that.
have time for very fewer questions, but
Yeah.
the way he's raising his hand is, I have to ask a question. So let's
Yes,
go.
please.
Your camera guy is blocking me.
Sorry?
Don't worry, you'll get recorded.
Oh, camera's blocking. Okay.
Sorry, I mean, have you considered using JRuby? I mean, wouldn't that also solve the issue of
Using what?
parallelism? JRuby.
JRuby, yeah? Oh, yeah, that's true. But we haven't used it before. So if you are already using JRuby, you're happy with that. Please don't worry about this. Because JRuby gives you these kind of things. But I'm only talking about people who are using MRI Ruby and trying to see, hey, can I get something, connection to concurrency or parallelism? Yeah.
All right, thanks.
Actually, I'm sorry to butt into that, but JRuby also uses the GIL.
Sorry?
No.
No.
Okay, just
Yeah.
checking. Then
JRuby
you're
doesn't
sorted.
do GIL.
Yes,
Okay.
sir. You've been looking at me for a long time. Hang on. The mic here, please. Had somebody else too.
Anybody else there?
Thank you. My name is Atmaram. I'm little more from other programming backgrounds.
Okay, that's a
and
difficult-
this question comes often that programming languages like Rust go offer fearless concurrency and concurrency at very high level of benchmarks. And this feature, when it is coming to Ruby, it looks promising for me to explore this language as well. But have there any benchmarks with respect to these languages, with respect to concurrency? It's like, is it like a lightweight threads that these programming languages offer, the Ruby has started offering?
Okay, so I don't think it's like fair for us to compare Golang and Rust with Ruby because those languages are designed for concurrency, right? But Ruby is not designed for that, right? But while we are using Ruby, we are still saying, okay, can we achieve something that these other languages are doing? We cannot say that, hey, we can replace Golang, you forget about learning Golang and Rust, use Ruby. No, I'm not saying that, right? So that's the thing. Yeah, one more.
As you said that in your earlier slide that the interpreter has a lock
Yes.
and that's why it can be run sequentially.
Yes.
So what happens in case of Ractor? I mean, the interpreter lock will still lock and it will process one thing at a time. Then how do you achieve parallelism with multiple CPU being used for, let's say, four different
okay.
processes?
Okay, with Ractor, what happens is, yeah.
So which means that there are kind of more interpreter which can be used for Ractor and they are like created dynamically.
I'm not pretty sure of how the underlying thing works here, but from what I saw, it says that it doesn't have it escapes the GIL because of the isolated blocks, so it is able to it doesn't run into the GIL problem.
Okay.
Yeah.
So, but then again, there are, okay.
Correct.
Access and all in threads actually. So in case of Ractors, if the process, it's every memory is processed isolated. That's why it doesn't
Correct.
come under GIL actually.
Correct. So did you get his answer? So what he's saying is, because of memory, it's, since the other things are sharing memories, there is a lock that is required for you to lock and then, give it to the other. But with the Ractor, there is isolated memory space, so you don't really need a lock there. Yeah. So it escapes that.